Welcome to Statistical Computing. Today we are going to explore the different categories of functions in C and C++. Understanding how data flows in and out of functions is one of the most fundamental skills you will learn as a programmer, and it will completely change how you organize your code. To start, imagine you are managing a busy restaurant kitchen. You, acting as the main program, need to delegate specific tasks to your specialized chefs, which represent our functions. When you hand a chef some ingredients, we call those arguments or parameters. When the chef finishes cooking and hands you back a completed dish, that is our return value. Depending on whether a function needs ingredients and whether it gives back a dish, we can divide all functions into 5 distinct categories. Let us look at the mathematics behind this. Before we write code, let us look at where this comes from conceptually. In mathematics, a function maps inputs to an output. Here, the variables x1 through xn represent the arguments you pass into the function. The symbol f represents the function itself, which does the actual processing. Finally, the variable y represents the single return value that is handed back to the main program. If you change any of the x inputs, the resulting output y will change accordingly. This exact mathematical concept translates directly into how we build functions in programming. Now that we understand the math, let us visualize the 5 categories we will be working with. Look at this diagram showing the data flow for each type. The central box in each row is our function, or our chef. Notice how the arrows change. Sometimes data only flows in, sometimes it only flows out, sometimes both, and sometimes neither. In the final category at the bottom, you can see a special case where multiple pieces of data flow back out. We are going to walk through each of these 5 categories one by one. Our first category consists of functions with no arguments and no return values. In this scenario, you do not give the function any data to work with, and it does not send any data back to you. It simply executes its internal instructions and finishes. Because nothing is being returned, we use the keyword void to tell the compiler what to expect. This type of function is highly useful for tasks that do not require data exchange, such as displaying a main menu, printing standard headers, or clearing the terminal screen. Let us see this first category in action with a concrete example. We define a function called printGreeting using the void keyword since there is no return value, and empty parentheses since there are no arguments. Inside, it simply prints a welcome message. When the main program calls this function, the text appears on the screen immediately. Notice that no calculations are handed back to the main program. The function does its specific job and quietly finishes. This is the simplest form of a function. Moving on, the second category consists of functions that take arguments but have no return values. Here, you provide the function with specific data to process, but you do not expect any mathematical answer back. Think of it like giving a painter a specific bucket of paint. You provide the color, they do the work on the canvas, but they do not hand you anything back. Because there is no return value, the return type remains void. This category is great for functions that save data to a file or display customized output based on user input. Let us look at how we write a category 2 function. We define a function called print_square. This time, we place an integer variable called number inside the parentheses. This is the argument we pass in, allowing the function to know exactly which value to multiply. Inside the function, it calculates the square and prints it directly. Because the return type is still void, the function just prints the result to the screen instead of giving the calculated number back to the main program. The data flows in, but nothing flows out. Our third category flips the previous one around. These are functions that take no arguments but do return a value. This means the function does not need any starting materials from you, but it will generate and hand back a useful piece of data. A real-world analogy would be looking at a wall clock. You do not give the clock any information, but it gives you the current time. In programming, this is incredibly useful for functions that read user input from the keyboard, generate random numbers, or fetch the current system time. Let us see how a category 3 function is structured. We define a function called getSensorReading. Notice that the parentheses are completely empty because there are no arguments. However, the word int is placed before the function name to show it will return an integer. Inside, it generates a reading of 50 and uses the return statement to send it back. The main program can then capture this generated data by assigning the function call to a new variable, like current temp. The data originates inside the function and flows out to the main program. Now we reach the fourth category, which is by far the most common in programming. These are functions that take arguments and also return a value. This creates a complete two-way communication channel between the main program and the function. You hand the function some raw data, it processes that data, and it hands you back a final result. Think of a standard calculator, where you input two numbers and it gives you back their sum. This category forms the absolute backbone of mathematical computations and data processing. To understand this two-way flow, let us look at its simplest mathematical form. If we want to calculate a result, we write y equals f of x. Here, the value x is the argument provided by the caller. It is the raw data going in. The value y is the return value coming out. If x increases, the function processes that change and the returned value y will reflect it. This is the purest representation of a category 4 function, where every input directly maps to a computed output. Let us put this two-way communication into code. We define a function called addNumbers that takes two integer arguments, a and b. Inside, the return statement calculates their sum and sends it back. In the main program, we call the function and pass in the numbers 5 and 10. The function processes these inputs and returns 15. We then store that returned value into a variable named total. We gave the function raw data and it gave us back a mathematically processed answer. This is how most of your computational code will be structured. This brings us to the fifth and final category, which deals with a special limitation in programming. A standard return statement can only send back one single value. But what if a function needs to return multiple values at the same time? For example, imagine a function that calculates both the area and the perimeter of a rectangle. A single return statement cannot handle this. To solve this problem and extract multiple pieces of information at once, we have to use special techniques. We will look at 3 different ways to achieve this. The first way to return multiple values is the traditional C programming method, using pointers. A pointer stores the exact memory address of a variable. By passing pointers as arguments, indicated by the asterisk symbol, the function can reach back into the main program's memory. Inside the function, we write asterisk area equals length times width. This directly updates the area variable back in the main program. We effectively return multiple results without ever using the return keyword. However, the complex asterisk syntax can be confusing and prone to errors. Because pointers can be messy, C++ offers a much cleaner alternative called reference parameters. A reference acts as a direct alias or nickname for the original variable, completely hiding the memory addresses. We create a reference by using the ampersand symbol instead of an asterisk. Inside the function, you simply write area equals length times width without any special symbols. When the main program calls this function, it directly updates the original variables. This achieves the exact same goal of returning multiple values, but the code is significantly easier to read and write. There is one more modern and highly recommended way to return multiple values, which is bundling them together using a struct. A struct is a custom data type that allows you to group several different variables into one single package. Instead of passing pointers or references, you define a struct that holds all your desired results, like area and perimeter. Your function then creates this struct, fills it with data, and uses a standard return statement to send the entire package back. This is the cleanest approach because it keeps inputs and outputs strictly separated. To summarize our journey today, the category you choose for your function depends entirely on what data needs to flow in and out. Remember to use the void keyword when no data needs to move in a specific direction. Rely on standard arguments and return values for straightforward single calculations. And when you need to extract multiple pieces of information at once, use C++ references or structs. Mastering these 5 data flow patterns is the absolute key to writing organized, professional, and bug-free programs. You now have the tools to structure any code effectively.